Hey Tensor Titans, are you ready to dive into the world of stock price prediction? Today we will build a machine learning model to predict stock prices using Python and LSTM. Predicting stock prices is one of the most exciting applications of machine learning. Although it's nearly impossible to predict the stock prices with 100% accuracy, we can use data-driven insights to assist in decision making. So today we will blend historical stock data, technical indicators, and deep learning to build our prediction system. So let's see what's going to be the game plan for today's project. We will start by fetching the stocks data with the help of the Y-Finance API. After fetching the stock data, we will perform some data pre-processing over it, like calculating RSI, adding technical indicators, and many more. After the data pre-processing, we will do certain data analysis over the data, and then we will split our data into the training and the testing set. After the training and the testing set, we will train our model on the training set, and then we will evaluate our model on matrices like MSE, and finally we deploy our model with the help of the Streamlit. So now let's jump into the coding part. So let me just quickly create an environment for our project and install the required dependencies, which are the libraries, into our project. So let's close the terminal and create a file app.py. So now let's quickly import all the required libraries for our project. So we will import Y-Finance as it allows us to fetch historical stock market data directly from the Yahoo Finance. It is super convenient and eliminates the need for manual data downloads. After that, we will import Pandas as it will help us to manipulate and clean the stock data. And then we will import NumPy for calculating the logarithmic returns or reshaping data for the model. And then we will import plotly.graph objects to create interactive and visually appealing charts. And then we will import sequential, LSTM, and dense from Keras, as we will use sequential to define our LSTM model, and the LSTM and dense layers are used for time series predictions. And from the sklearn, we will import min-max scaler and train test split. Min-max scaler normalize stock prices to a range between 0 and 1, which helps the LSTM model to perform better. And train test split will help us to divide our data into the training and the testing sets. And finally, we import Streamlit, the framework we will use to build our interactive web app. Now we will create a dictionary model cache. In this, we will storing our model and the scaler. So next, we will create a function to fetch stock data. Here yf.ticker symbol creates an object representing the stock. For example, if the user selects Apple, it will fetch all Apple related data. And after that, we will create a variable data in which we will type stock.history period is equal to 5y. It retrieves 5 years of historical stock data. This gives us enough data for training while keeping it manageable. And after that, we will return the closing price, as these are the most relevant for our prediction model. Now we will pre-process the data and calculate the technical indicators. So we will create a function pre-process data. In this, we will create a SMA 50, as it is the 50 days simple moving average. It smooths out price fluctuation and helps to detect the trends. After that, we will calculate EMA 50. It is the 20 days exponential moving average, which gives more weight to recent prices, making it responsive to market changes. After that, we will calculate the daily return, as it is useful for short-term trends. And then we will calculate log returns, as it provides the logarithmic returns, which help us to model the financial because these handle compounding well. After that, we will calculate the RSI. For calculating the RSI, we will first calculate the gain and the loss. After calculating the gain and loss, we will calculate the RS value. RSI measures the momentum in the market. A value above 70 indicates overbought, and the value below 30 suggests oversold condition. And then we will add the boiling bands. So boiling bands consist of a middle band, which is a 20 days SMA, and upper band, which is 20 standard deviation above, and lower band, 20 standard deviation below. After that, we will add momentum and volatility. And momentum measures the change in the price over the last 4 days. It is a quick way to see whether prices are accelerating or decelerating. After that, we will add the volatility. This calculates the 20 days, 21 days standard deviation of the closing price, which represents market volatility. And then we will drop the rows with missing values caused by the rolling calculation. This ensures the data is clean and ready for modeling. So before feeding the data into our model, we need to normalize it. So here min-max scaler scales the close price to a range between 0 and 1. This normalization helps the LSTM model converge faster during training. And then we will return both the scale data and the scaler, which we will use later to reverse the scaling. So next we prepare our data for time series prediction. This function creates sequences of 60 days of stock prices to predict the next day's prices. This sliding window approach is perfect for LSTM model because it mimics how stock prices evolve over time. Now we will start building our LSTM model. So we will define our LSTM model itself. Sequential is the simplest way to define a neural network, stacking layers one after another. So the first layer will be the LSTM layer, which have the 50 units and return sequence being true to pass its output to the next LSTM layer. The second LSTM layer processes the sequences and output a final feature vector. And then dense 25 is a fully connected layer with 25 neurons for additional processing, and dense 1 outputs a single value, the predicted stock price. We will use the Adam optimizer for efficient training and mean squared error as the loss function, which measures how close our prediction are to the actual prices. Now we will build the interactive interface with the help of the Streamlit. So first we will set the title of our web app, which is stock price prediction, and then we will provide user with a drop-down menu to select a stock symbol from our predefined list. So we will create a stock list in which we will define the symbols of the stock, and then we will create a drop-down select box for the user to select the stock symbol. So once the user selects a stock, we fetch its data, display the latest closing price, and update them on the progress. And now the real magic happens. When the user clicks this button, we start training the model and predicting future prices. If the model for this stock is already trained, we retrieved it from the cache. Otherwise, we pre-process the data and normalize it. We split the data into training and the testing set, build the LSTM model, and train it for 5 epochs. This is where the model learns pattern in stock price movements. After training, we evaluate the model on the test data and cache it for future use. Now let's generate predictions for the next 10 days. So we start with the last 60 days of data, predict the next day, and append the predicted price to the sequence for the next prediction. This process repeats for 10 days. Finally, we reverse the scaling to get predictions in actual price values. And after that, we will show the predictions in a table and chart. We create a data frame with the predicted dates and prices displayed in a table and then plot it. Here we plot the predicted prices as a line chart with markers. The plotly dark theme makes it visually appealing. Now let's check if it's working or not. So as you can see that our stock price prediction model is working good. So now let's deploy our model. So firstly we will create a requirements.txt file. So pip freeze requirements.txt. In this file there will be all the required dependencies for our project. Now we will create a GitHub repository for our project. So let me just quickly create a GitHub repository for our project. Now we will copy this code and in our terminal we will type git init, and then we will add the required files in our GitHub repository. So git add app.py requirements.txt, press enter, and then we will paste the code over here, and then we will press enter. So now as you can see that the required files are pushed into our repository. Now we will deploy our model. So we will again run our project streamlit run app.py. Here we will click on the deploy now, and then we will copy the URL for our app.py file and paste it over here. Now let's name our app. So stock price prediction. So it's not available, so we will put a 0. So now let's wait while it's deploying our project. So yes, now you can see that our project is deployed. Now let's see if it's working or not. So our project is working fine. So that's it for today's guys. If you like the video, do like, comment and subscribe to our channel for more exciting machine learning projects.